Okay, good evening. Welcome to Family Math number 3. And today we're going to learn about
infinity.
Awesome. And specifically we're going to learn about, kind of crowded in here today, but we'll figure it out. We're going to learn about something called countable infinity.
Countable.
Okay. And this is going to sound silly. Are you ready for something that sounds a little silly?
Yeah.
This is the smallest kind of infinity. Okay? And this is the infinity that you can count to. That's why it's called countable infinity. So it's the infinity that you get from the counting numbers. 1, 2, 3, 4, 5, all the way up to infinity. Now, do you know why? Not up to 8. Up to sideways 8. Do you know? Go ahead. Now, do you know why I didn't write all the numbers all the way out to infinity?
Yeah, you can't.
Would have taken too long.
Yeah, you can't.
Yeah. So, but now we're going to learn about some really interesting things about countable infinity. Okay? So, what if I only counted every even number instead of all these numbers? So what if I just counted 2, and I skipped 1, I counted 2, skipped 3, 4, I skip 5, and then I get 6, and I skip 7, and I get 8. Now, do you think I'm going to have more numbers in this list, or more numbers in this list?
I keep doing.
So look, when I get out here, I have 1, 2, 3, 4. Like when I hit 4, I have 4 numbers already. When I hit 4 here, I only have 2 numbers. When I hit 6 in this list, how many numbers do I have?
6.
When I hit 6 in this list, you tell me, how many numbers do I have when I get to 6 in this list?
6 in this list.
1, 2, and
3.
3. Very good. Now when I get to 8 in this list, how many numbers do I have?
4.
And when I get to 8 in this list up here, 1, 2, 3, 4, 5, 6, 7, 8, how many numbers do I have?
8.
8. So which list do you think is going to have more numbers?
This
What do you think?
one. Same.
That one? Now here's one of the crazy things about infinity. These lists have the same number of numbers.
Wow.
Can you believe that? Even though this list has numbers that this list doesn't have, and this list, all the numbers in this list are in this number. Now, do you want to see why?
Why?
Okay, you ready for this?
Yeah.
This is crazy. Now, you remember the distributive property?
Yeah, I do.
I can factor a 2 out of all of these numbers, right? Factor a 2 out of that, factor 2, factor 2. And this list becomes 1, 2, 3, 4, 5, all the way out. Now, where have you seen that list before?
All the way up there.
Up there. Isn't that weird? The even numbers have the same number of numbers as all the counting numbers.
Whoa.
Okay? Now what if I did something really crazy? Okay? Now what if I did something really crazy? So instead of going 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. How about if I did all the squares? Do you know what squares are?
No.
1 times 1, 2 times 2, 3 times 3,
Oh, yeah.
4 times 4. Okay. So instead in this list I got 1, 4, 9, 16, 25, 36, 49, 64, 81, etc. All the squares. Okay. Now when I get to 4, and I have these 2 lists, right? This one has all the counting numbers. 1, 2, 3, 4, 5, 6. Right?
Set up.
This one has only the perfect squares. 1. When I get to 4 on this list, I only have 2 numbers. But when I get to 4 on this list, I have how many numbers?
4.
When I get to 9 on this list, I have 3 numbers. But when I get to 9 on this list, how many numbers do I have?
9.
When I get to 16 on this list, I only have 4 numbers. When I get to 16 on this list, how many numbers would I have?
16.
16. Okay. When I get to 25 on this list, how many numbers would I have?
Only 5.
And when I get to 25 on this list, how many numbers would I have?
25.
Wow. So which list do you think has more numbers?
This one.
That one?
I think they're the same.
You think they're the same? Why? What tricky trick can we do?
You can use that distributive property.
Well, I can't factor anything out that's the same, but I can write them like this. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, etc. And now they match up 1, 1, 2, 2, so that I can count the numbers in this list.
Cool.
Okay? Isn't that interesting?
Mm-hmm.
So it's a strange thing about infinity. Lists that seem like they have fewer numbers, when you go all the way to the end, have the same amount of numbers. Even though you're skipping over numbers that are in our original list. You want to do it for one more thing?
Yeah.
What do you want to do? So we did even numbers and we did squares. What do you want to check
Perfect
next?
cubes.
Perfect cubes? Okay, awesome. Let's see if we can do the same trick and find a clever way to count the perfect cubes. Cubes are 2 times 2, well, first 1 times 1 times 1. 2 times 2 times 2. Here, step in. 2 times 2 times 2. Do you know what 2 times 2 times 2 is? Or actually, do you know what? I probably have to write. I'll write them as times is. So what's 2 times 2?
It's 4.
And what's 4 times 2 then?
6.
No. 4 times 2 is 4 plus 4, which is
8.
8. Very good. And now, how about 3 times 3 times 3? Well, do you know what 3 times 3 is?
That's going to be 9.
9, right. And then 9 times 3 means 9 plus 9 plus 9. And that's going to be, should I just tell you?
27.
27. How did you know that? How did you know that?
I just knew it.
You just knew it? Good job. Okay, so our perfect cubes are going to look like this. 1, 8, 27, 64. You know what 5 cubed is by any chance?
125.
125. How about 6 cubed?
No.
216.
Oh, I think I've heard that before.
Yeah, I think you have 2. 7 cubed is 343.
Haven't heard that.
8 cubed. Do you have any guesses?
64 times 8. No, I don't.
It's 512. And then 9 cubed is 729.
I think I knew that.
So look how big these numbers get. Like when we get to 125, we've only got 5 numbers. But in this list, we would have 125 numbers when we got to 125. All right, now here's a challenge problem. How many numbers do we have when we get to 729 in this list?
9.
9. But if in this list, how many numbers do we have when we get to 700?
709.
Oh my gosh, so this list has to have more. But you know what? When you go all the way to infinity, which list has more?
9.
They're the same. Isn't that crazy?
You can rewrite it.
Because you can count these by doing this. 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, etc. So this list also would go 1, 2, 3, 4, 5.
Awesome.
Awesome. So this is the smallest kind of infinity, and it's called countable infinity. And you start seeing that infinity has some strange properties that you don't usually think of that other numbers have. Isn't that neat?
Yeah.
Sometimes more is not more. And sometimes less is not less. Sometimes they end up being the same. Pretty fun. Should we do some more infinity videos?
Yeah.
Okay, awesome. Good job, guys.